So you already have these notes on the first part of Lesson 1-6. I gave you this handout before we took the chapter test, and we did the beginning of these notes. So at the top of it, it says Lesson 1-6, Solving Absolute Value Equations. So I wanted to do these last two problems and just remind you kind of what we talked through before, and you're going to be doing a few of these problems for part of your assignment for tomorrow. So remember that with absolute value equations, you should be getting two answers, which means you need two equations. So we're going to have two separate equations, which is what we did up here. Remember, you're making two equations and you're setting it equal to the positive and negative of the number on the other side of the equation. But you have to have the absolute value by itself first. So in a problem like this one, if the absolute value expression is not alone, you have to undo what's being done to it so you can get it by itself. And then you make your two equations. Okay, now something a little different is going to happen on this next problem. So on this one, the first thing that we're going to do is get the absolute value by itself, which means since 7 is being added, we're going to subtract 7 on both sides. So then we'll end up with x, the absolute value of x minus 3 is equal to negative 5. Now, based on what I told you before, you would think, okay, I'm going to make my two equations. I'm going to make x minus 3 equal to 5, or x minus 3 equals negative 5. And you could solve it like we did above, and you would have to check it as we did above also. Now, the thing about this one is it's different because when you look at this equation right here, something is different about the previous than the previous problems. That negative right there is meaning that you have the absolute value isolated and it's equal to a negative number. So think of it like, what number has an absolute value that's equal to negative 5? Well, there isn't any, because absolute value means the distance from 0 on the number line, and there are no numbers that are negative 5 units away. It doesn't make sense for a distance, right? Absolute value has to be 0 or positive, so there is no number that would satisfy that. So if you notice at that step, so in our previous step here, I'm going to get rid of what I wrote down here. In our step right here, if you notice that you have the absolute value isolated, it has to be alone. Okay, if it's not in that format, then this won't work. You have to have the absolute value expression alone. And the other side is negative, then you can stop and say no solutions. Empty set, or just write the words no solutions. Now, what's going to happen if you don't notice that? Well, you'll do the same thing you did up above. You're going to have to take, if you set equal to 5 and negative 5, you find two answers. When you check them, what's going to happen? Well, they won't check. And so at that point, you can catch it and be like, wait, I'm not getting negative 5 when I take the absolute value on the left side, so that means that there's no solutions. But if you notice it along the way, then you can save yourself some time and just say, okay, absolute value can't be negative, no solutions. And then in our last problem here, we're going to do the same first step, get the absolute value by itself. Just pretend like if you had a variable plus 5 equals 5, what are the steps that you would do to get by itself? Well, you would subtract 5 on both sides, right? That's the same thing that you're doing on these problems. So pretend like the absolute value expression is a variable that you're trying to solve for. So we would be subtracting 5 on both sides. And that's going to give us the absolute value of 2x plus 3 is equal to 0. Now, when you go to make your equations, what do you notice? Well, if you try to say 2x plus 3 equals 0 and 2x plus 3 equals negative 0, negative 0 is the same thing as 0. So you don't really need two equations on this one. This is the only situation in which you'll only get one answer. So then you just solve it like normal. We're going to subtract 3 on both sides. So we have 2x equals negative 3, and then divide by 2, and we'll have x equals negative 3 halves. Now, when you go to check this, we'll be plugging negative 3 halves into the original equation here. So we're checking that negative 3 halves. So our check, and you're always checking these equations. Absolute value of 2 times negative 3 halves plus 3, and then add on 5. We want to know, is that equal to 5? We're just simplifying the left side and seeing if it's equal to the right side. So how do you multiply 2 times -3/2? Well, I'm just going to make that 2 a 2 over 1, right? Because you're multiplying fractions. You multiply the tops together, and then you multiply the bottoms together. So tops get multiplied, bottoms get multiplied. So when we're simplifying this, we'll have the absolute value of -6/2 plus 3, and then again we're adding on 5 on the end. So it's the absolute value of -3 plus 3, and adding on 5. That's the absolute value of 0, which is 0, and 0 plus 5 is 5, which is equal to what our right side was. We were trying to check and see if the left and the right sides were the same. Alright, so that's the end of this example. You need to make sure that these notes are filled in, and I'll check that tomorrow along with the problems that I'm assigning on Schoology.